Okay, I'm going to discuss now example page 18 here, example 2.7.1, question F. Alright, so this is the question. Use the transformation u equals to y over x. Okay, so this is the transformation. V equals to xy given in the question, so you must follow what is given in the question. And then you have, this is the thing that you want to evaluate, where the four lines or the four curves are this 1, 2, 3, 4. Okay, so we're going to discuss that question now. Okay, so basically this is it. Okay, so the original one, you have this and this, and you have this is the UV transformation. So maksudnya you kena jadikan your function ni in terms of y over x, and another pair is xy. So the idea is, you can see that this one here, as I told you before, you must make sure on the right hand side ni adalah nombor, on the left hand side is the one with the variable. So you can see yang ini you buatlah y bahagi x. You can see what you have is y over x equals to 1 over 2. And then this, the second one, y over x equals to 1. And then this one, x boleh bawa ke sini, you have xy is equals to 1 and xy is equals to 2. So we are already in the form where on the left hand side are all variables xy, and on the right hand side is constant. Okay, so you can relate these two. You can see that you have now u is equals to 1 over 2, u is equals to 1, v is equals to 1, and v is equals to 2. Alright, so we sketch this. What you will have now is u, v. Okay, so basically this is your sketching. So now we have got already the form that we want. So the question asks you to find, okay, we want to find this. Alright, so what we do is we change it into the UV form. We need to have it as in the form of e power of xy ni. You can see that based on the UV transformation, xy is actually v, so we can straight away change it. And then dA ni adalah the Jacobian of xy change kepada UV. And then you have du dv. So v ni you tengok the range is from 1 until 2. And your u is from 1 over 2 until 1. What next is, we want to find the Jacobian. So we have got everything here except for the Jacobian. Okay, so what we have now, this is how you want to find the Jacobian. The formula is, you have the Jacobian xy terhadap uv ni yang you nak cari is equals to the reciprocal. So I mentioned before why we use the reciprocal case. So we find this one, du dx, du dy, and so on. Okay, so du dx is based on this. You derive it in terms of x. What you will have for this one will be, alright, so basically you derive this terhadap x. Maksudnya you have u equals to y x kuasa negatif 1, right? So you derive this. What you will have will be negative x kuasa negatif 2y. Alright, so di derive ni terhadap y, you akan dapat 1 over x. Kan deriving x, y akan jadi constant. Deriving terhadap y, x akan jadi constant. So you should know the basic. So dv dx, deriving this terhadap x, terhadap x dahulu, you akan dapat y. Deriving this terhadap y, you akan dapat x. So darab silang, you akan dapat negative of y over x square, and you have x over 1. So in the end you have it here is equals to negative y over x. Alright, so you need to change this in terms of uv. So you can see that u equals to y over x. So what you will have now is actually this one is actually, okay, so I make a correction here. Tolak dengan y over x kat sini. Alright, so alright, what you will have now, negative 2y over x. So y over x adalah u. So negatif 2y over x adalah negatif 2u. So bila you buat reciprocal, okay, bila buat reciprocal, 1 over this will be equals to negative 1 over 2u. Alright, so sekarang kita masukkan dalam kita punya integration. Okay, so satu benda yang you kena tahu, bila you dapat negative value kat sini, you tak boleh moduluskan kat sini sebab this represent matrix, bukannya modulus. Alright, this one is the one with the modulus. Okay, so maksudnya apa yang you akan dapat sekarang adalah, okay, sekarang ni saya moduluskan ini, saya keluarkan 1/2, so in the end this is the thing that you want to integrate. So the next thing you do adalah integrate lah. Alright, okay, just continue with the process of integration. So this will be your final answer. Alright.